Okay, so this is 7th grade, 2nd semester, Unit 2, Lesson 1. Vocabulary review. State the commutative property of multiplication. Who remembers the commutative property of multiplication? We covered this in the first semester, actually in the first quarter. Does anyone remember commutative property of multiplication? Quinn, yes. Adipogeu? You're thinking multiplication property of equality. Okay, that's solving equations. This is something else. Kayla? That's exactly correct. I don't know if you heard what Kayla said. She said, let me use some vocabulary. I understand what you're saying. So the answer, what is the answer of multiplication of two numbers? The product of two factors is the same whether you change if you change the order around. Okay? So let me show you algebraically what that means. If I have a number a, and I multiply that to a number b, then that would be equal to the same number a, the same number b, multiplied in a different order. Do you guys understand? Okay, this is the property, this is the algebraic representation of the property. Now, if we were to come up with an example, can you give me a number between 1 and 10 for A? 7. I heard 7. So 7. And give me a number for B. 2. I heard 2. 2. So if I double 7, if I add 7 to itself twice, what do I get back?
14.
Right, you get back 14. If I add 2 times 7 is saying, hey, add 2 to itself 7 times. 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2 is, it's still going to be 14. And so here's an example. And here's the property. Okay? So here I give an example, and then here's the property. Okay? So moving along, find each product. Now for number 2, there's a shortcut. Does anybody remember the shortcut? If you multiplied it out, great. But if you know the shortcut, can you share with the class the shortcut? Because we've reviewed the shortcut a number of times so far. Nathan.
So there are 2 zeros and 100. So you move the decimal point in 4.5 2 places to the right.
Nice, very good. So Nathan said because 100 is a power of 10 and there's 2 zeros there, we're going to move our decimal place 2 places to the right. And so if you have 4 5/10, first you'll have to add a 0 because we run out of digits, right? Okay? And because we don't have enough digits to move it 2 places, we add that 0, 1, 2. That puts my decimal right there at the end. So what is my answer going to be? 450 is the answer. Okay? If you want to multiply it out and verify it, that's fine. You'll still get the same result. Now for number 3, can somebody share with me their answer? And then we'll work it out. Jayla, what's your answer? 28 and 8/100. Let's take a look. Did everybody else get that answer? Let's verify. So 2 and 34/100 multiplied by 12. A little bit of review. 2 times 4 is, class, 8. 2 times 3, 6. And 2 times 2, 4. Now before I multiply the next digit over, I have to do what? I got to put a 0 in there, right? The place value. Now I can multiply the 1. So let's go and do that. What's 1 times 4? What's 1 times 3? And 1 times 2? Okay. Now we're going to add all this up. And when we add all this up, we get 8 plus 0, which is what? 8. 6 and 4? 10. I'm going to put a 0 here and carry the 1 from the 10. 4, 1, and 3 is what? 8. And then 2 by itself is 2. Now, if you notice, 12 has the decimal at the end. So I don't consider that any places to move, so I put a 0 here. Now here, for a 2 and 3400ths, it's 2 places in. Okay? So 2 and 0 gives me 2 places that I have to move it to get my final answer. So 1, 2, so it's 28 and 800ths. Okay? Very good. When you're done, just click Save, and then turn your desk around. For number 4, who's got number 4? Henry. 58 and 200ths. Yes. Did you guys get that? Okay, let's verify. Somebody, it sounds like somebody might have got a different answer, so let's check it out. So I got 10 and 200ths. I'm going to multiply that by 5 and 6/10. 10 and 2/10. Sorry, I said hundreds, didn't I? Now let's multiply this out. So first I need to multiply the number in the ones place. 6 times 2 is what? 12. Carry the 1. 6 times 0 plus the 1, 1. Now I got to multiply 6 times 1 is going to be 6. Olu, you had a question? Okay. Now before I multiply the 5, I got to do what? I got to put a place value holder there, annex to 0. Okay. So now I can go ahead and multiply the 5. 5 times 2, 10. Carry the 1. 5 times 0 plus the 1. And then 5 times 1, 5. So let's add all this up. 2 plus 0, 1 and 0, 6 and 1, and then we got 5. All right, is that what we got? Okay, now my decimal, here it's in one place, so I got 1. Here it's in one place, so I got another 1. So that means I got to move it 2 places. So 1, 2. So it's 57 and 1200ths. Is that what we got? Yeah. Any questions?
May I have Jeremy Mercado for early dismissal, please? Jeremy?
Yes, he's on his way up. Jeremy, we have homework due for tomorrow. Okay, and last but not least, let's take a look at number 5. Who's got number 5 for me? Jason? Can you say the name of that number? I know you're giving me the digits, and it sounds like they're correct, but we have the part coming up soon. They're going to want you to be able to name the number. Can you give me the correct name for that number? 2 and 400ths. Did you guys all get 2 and 400ths? Yeah. Okay, let's go and multiply this out to verify. So 3 and 4/10, 6/10. We're going to multiply this out. 6 times 4, 24. Carry the 2. 6 times 3. 18 plus the 2, 20. We don't need to multiply that 0, but we do need to figure out where my decimal is going to be. So I have 1 place here, 1 place here. That means I got to move it 2 places, right? So 1, 2. So it's 2 and 400ths. That's what we got? Okay. Now let's move on to the lesson. What you'll learn: to find the area and perimeter of a parallelogram. New vocabulary. Height of a parallelogram, base of a parallelogram. Why learn this? The floor plan of the building at the right is in the shape of a parallelogram. You can calculate the area of a parallelogram to determine how much office space is available on a given floor of the building. So why is that important when we're talking about real estate? Why is the area of floor space important? Yep.
Because when you're looking for a house, you might be looking for like certain rooms to have a big amount of space in it. When the people who are building the house, they plan the rooms wrong.
Right. So whether you're renting, You could be renting a place or buying a place. In this case, you're renting office space for your business. They charge you by how much space you're renting. Does that make sense? So if they're talking about the square footage, that's typically what they talk about when they're talking about real estate. They're saying how many square tiles that are 1 foot by 1 foot will fill up all the floors in that rental. Does that make sense? And the more square footage, the more expensive it'll be. Does that make sense? Okay, so whether you're buying a home or renting a place, or maybe you're renting a place for a business you might have, that's how they calculate that. Okay? Now this building, it's not, if you look at it from above, it doesn't look like a rectangle or a square. It looks like a parallelogram. And so sometimes, have you guys ever driven through DC and seen some really weird shaped buildings? Well, they build it as big as they can inside that area between the streets, right? Okay, and there's a really weird looking library off of, I think it's 8th Street near Chinatown. It's by Shaw. It's got looks like a parallelogram. I can't say it's definitely not a rectangle or a square, because the building comes to a really sharp angle. Have any of you been to the new library in Silver Spring near the movie theater? That has a really weird shape to it too. All right, so let's take a look. And if you know how to find the area of a rectangle, then finding the area of a parallelogram is pretty easy. So first we need to identify what are the key things to look out for in a parallelogram. Well, here's what you look out for. First, you got to know what the height of the parallelogram is. You can't find the area of a parallelogram unless you know the height of it. Okay? The height of a parallelogram is the length of the perpendicular segment connecting the base of a parallelogram to the other base. So if you notice this parallelogram, these two sides that are in blue, those are the bases. Okay? And the height is the perpendicular distance between those two bases. The key word is perpendicular, and perpendicular means that they intersect at what type of angle? A 90-degree angle. So when you see these in a test or a quiz, they might flip this around and try to confuse you. There's a few ways they might, but we're not going to fall for the tricks, okay? Mm-hmm. I'm about to show you something I think that ties in with what you're saying. Okay? So let's take a look. We know the area of a rectangle is what? Length times the width. Now, length and width, you could think about that in another way. If you look at this wall behind me, it's a rectangle, right? Okay? And do you guys see along the bottom of the wall, do you see that, the part that's black, like the stripe along the bottom of the floors? Okay. Does anybody know what that's called?
Nope.
It's called a baseboard. And a lot of times a home or part might have a baseboard throughout the home. Sometimes they do, sometimes they don't. We have a baseboard in this classroom. And if you think about that, that's the length of the wall or the base of the rectangle that forms this wall, right? Okay, and from the floor to the ceiling, we could think about that as being the height of the wall. Do you guys understand? So if I want to know the area of this wall, I can multiply the base times the height. If I put it flat, I can think about that as length times width. Do you guys understand? I'm trying to make that connection here, because if you look over here at what I have on the smartboard, here's my rectangle. It's just a general rectangle. The area of the rectangle is length times width. And I'm color coding it blue and red for a reason. If you look, I can take a chop out of my rectangle that meets at the vertice of one of the corners, and watch what happens. You guys see this? If I take that little chunk out, I get a corresponding parallelogram. Do you guys see that? Now, if you notice, the base is still the same. It's still the same from the original one. Do you see that? I didn't change the base. The height, it's still the same as the width. My height, it's still the same. Do you see that? I didn't change that. Laura?
Can you do the height on the other line too?
This one, I just showed you that I broke it into two pieces. The one in the middle. This one?
Yeah, the one. There's a part of this.
You want me to put that height over there too?
No, the other side. The other side of the same parallel.
Oh yeah, I can see the height's still the same anywhere along it.
Okay, good.
Right? Everywhere along it's the same. Because these two sides are parallel. They never change angles. They stay the same angle. They never intersect. That's why the height is important. I think I understand what you're saying now. Okay, now you don't know that you have the height unless you have a little box there that says it's at a right angle. Do you understand? So I'm just trying to use this to illustrate things, but in the questions they're going to give you that little box to tell you. Okay, now that leads us to the key concept. So when we talk about base and height, use that interchangeably with a rectangle length and width. Okay? Is this what they showed you, something similar? Yeah. All right, so Kalila.
Are the sides always going to call base and height? Or is it gonna
Be ready to use them interchangeably. Be ready to use them interchangeably. Okay? So if you look, now we have two other ways that you can see a parallelogram. And again, I try to color code it. If you look, here's my height, and there's my base for the first one. But over here, my base might be represented this way. They might have the height drawn outside of the parallelogram. Do you see how it's outside of the parallelogram? You have to understand, like they're saying, this is not really part of the parallelogram. It's just telling you what the height is to the other base. From one base to the other, that is the height. You understand? Any questions? And the formula says the area of a parallelogram is equal to the product, means multiplication, of any base and corresponding height. Yep. Yeah, most of the times they'll have it as a dotted line. Sometimes they won't. Sometimes they'll just draw a segment and label it as being perpendicular to the two bases. You just have to know, like, that is the height. Right, or they might give you a drawing where they have a bunch of different polygons, and they're going to say, hey, find this area of this part of the polygon, or this part of the figure. Do you understand?
Please pardon the interruption. 8th grade teachers are mostly affected by this.
See if you can solve this.
And will be coming back into the building.
Here's a
They
sample
will
problem.
resume a normal schedule as they normally would if they were here during the day. 8th grade students are coming back in and should be returning to a normal schedule. Thank you.
Okay, so I give you the formula. Here's the formula. Now, can somebody tell the class what is the base of this polygon? So from the picture, you have to identify what the base is. If you don't know what the base is, you're going to be stuck. Joshua?
9 inches.
It is 9 inches. Very good. So that's the base. The base is 9 inches. And I need to multiply that by the height. And what is the height going to be? Continue. It's 23 inches. Okay, so what does my area end up being? What is 9 times 23? Dominic?
207.
It's 207. Now here's the part I want to focus on with you guys. When we're dealing with the units, you treat them like a variable. What's x times x times x? Use an exponent. X to the third power, right? Or x cubed. So what would x times x be? X to the second power, or x squared. Now, inches times inches would be then what? Inches squared. Now, it's inches to the second power, but there's a reason why they use squared for the second power. Because what this question's answering is, hey, in this parallelogram, how many square inches would fit in that parallelogram to cover up all the area inside the shape? 207 square inches would cover the entire parallelogram. Does that make sense? Okay, I believe. Yep, go ahead.
And so for like, this is kind of like a bit unrelated, but like we use cubic for volume.
Right, so
It's
I
different.
like that you brought that up. So volume is a container, right? And so when we measure volume, we're asking ourselves, how many cube units, or if I had a dice, and that dice had edges that were inches, how many cubic inches would fit inside that container, right? So when we're talking about surface area, we're talking about a flat space, flat area. We're saying how many flat squares would fill this up. Does that make sense? Okay, so conceptually that's important. All right, so make sure you label your units. That's very important for getting full points. Question? After she gets back. Question? After she gets back. Okay, now that we've done this problem, I need you to sketch this out. Doesn't have to be beautiful. Sketch it out so you have your notes and answer the question. This should be a really quick one, maybe 30 seconds top for you to sketch this out in your notes and answer the question.
Why did you put the exponent after inches?
Because we're saying inches are multiplied to themselves twice. So if we go back up here, 9 and 23, those are numbers I can multiply them together. Inches and inches, they're the same unit. I can multiply those together. So inches times inches is inches to the second power. That's just saying that I'm multiplying inches to itself twice. Okay? Yes, it is. That's a unit. You have to label it. Nathan, you have a question? Okay, walk me through it. First of all, what's the formula for parallelogram? Formula? The area of a parallelogram. Mm-hmm. Or base times height. Okay. Now, can you go ahead and give me what you got for the base? Very good. So the base of the parallelogram was 9 centimeters. And we need to multiply that by the height. And what did you find for the height? 10 centimeters. Very good. And so make sure you give me this in the correct units. What is the area of this parallelogram going to be? Nope. What do you leave out, guys? 90 centimeters squared. Okay? Now, the next problem's a little bit challenging. So I need to go back and remind you of some things that we know. Okay? Before I go to the example, you can use the length of the sides of a rectangle to find perimeter. So can somebody tell me, if I wanted to find the perimeter of a rectangle, how do I go about doing that? How do I find the perimeter of a rectangle? Kalila. No, you're not going to multiply all the sides. I'm going to give somebody else a shot. Lola.
You add up the length of all the sides.
I add up the length of all the sides. So let's think about it this way. The perimeter is equal to the length plus the... So if I was to start in this corner of the room and I walked that side of the room, that would be a length, right? Okay? And then if I walked along that wall, that would be the width. So the length plus the width, all right? But I have to do a full lap for me to find the perimeter, right? So I have to keep walking. Now I got to walk along that wall, which would be the same length as this wall that I already walked earlier. So length plus width plus length. Now I'm over here, but have I returned to where I started? No, I got to do a full lap. So I got to walk a what? A width. So W. So here's the formula for perimeter, but that's not typically how the book's going to show it to you. The book is typically going to show it to you another way. Here's how a book's going to show it to you. Now, if I was to combine like terms, what can I combine? I can combine the L's. So if I put these L's together, what would I get back?
L squared.
No, that's multiplying. L times L is L squared. If I'm adding L's together, now I have two of them. So I can get rid of one and say, hey, I have 2L. But now I got to take care of my W's, right? So now I have these W's, right? So what's W plus W? Very good, 2W. So now here's the formula that you typically see in a book. It's going to be 2 times the length plus 2 times the width. Okay, yep.
You just said that perimeter is length, adding up the lengths from each side.
Right, but in a rectangle, you have 2 sides that are the same, right?
Yeah.
So I can say 2 times the length, right? Yeah, if I add L twice, that's the same as multiplying by 2. Okay, you said multiply all the sides. That's not what you're doing. We're not multiplying all the sides. I'm adding L twice, so that's double L, right? Okay, so I'm just trying to relate the formula from the book to what was said.
Good afternoon, teachers and students. Pardon the brief interruption. Just a heads up that our 8th grade students are coming back into the building and they will resume a normal schedule for their 6th period class. Again, their 6th period class. Students will resume a normal schedule for their 6th period class for 8th grade. Thank you.
Now, for those of you that did the distribution portfolio, this part should look very familiar to you. Do you guys remember this? So, do you remember I can distribute the 2 and go back a previous step? Okay, isn't 2 times L 2L and then 2 times W 2W? Okay, I factored out the 2. Okay, I did reverse distribution. Okay, now there's a reason why I'm doing this, because we're going to use this to answer our question, the example, relating perimeter and area. Here's the multiple choice. Those are your answer selections. Melinda wants to plant a rectangular garden and put a fence around it. Okay, so she has 34 feet of fencing, and she wants her garden to be as big as possible. Which dimensions should she use? Okay, so they give us 4 possibilities. Now, what information are they giving us? We have a lot of unknowns. We have a lot of things that we don't know, but we have something we do know. What do we know? Adipoji? We don't know the lengths and the widths. What do they give me in the questions? What does she have?
34 feet of fencing.
Okay, right? She's going to use that to go around her garden, right? No, it's L. It is typically written in lowercase, though, okay, for those variables. So we do know that she has 34 feet of fencing, and that's what she's going to put around the perimeter of the garden, right? So she knows how much perimeter she's going to have, which is 34 feet. So I'm going to replace for P 34. And then everything else, I'll keep the same. Okay, so we have 34 feet equals this. Okay, so do you guys see how I went from here to here? All right, now I want to get this part by itself. L plus W is being multiplied by 2, right?
Yeah.
So how do I get rid of the times 2?
Divided by 2.
I'm going to divide both sides by 2. Okay, and then we see that this cancels, and this cancels, they become 1. And 34 divided by 2 is what? We get 17. And 17 equals L plus W. Okay? So, the length of her garden plus the width of her garden is going to be 17. Well, which one of these is that true for? Let's take a look at our answer selections. Is it true for A? Yes. 9 plus 8 feet, does that give me back 17?
Yes.
So this one could be a possible answer. What about selection B, 10 and 7? Will that give me 17? That's another possible solution. What about C, the length of 12 feet and 6 feet? What's that give me back? Does that give me back 17? No, it gives me back 18, so that is not a possible selection. What about D? That's 19. That's not a possible solution either. So now we have eliminated half of our choices. We have 2 left. But the key is in the question. What's she trying to make out of this garden with this fence? The biggest. She wants the biggest garden possible, right? So how do we eliminate one of these choices? Kayla? Very good. We're going to find the area. What would the area of choice A be? 72 what? Feet squared. Very good. 72 feet squared. Excellent. And what would the area of choice B be? 70 feet squared. So, what's my answer going to be? A, because that's the largest garden from those two possible choices. So we see that this is not a possibility and that our answer is choice A. All right. So understand that question, but now let's see if you guys have the knowledge to solve this next problem. Here it is. Here's your figure. What is the perimeter of the rectangle? Well, we don't have all the information we need. You need to come up with a strategy to get the parts you need so you can answer the question. Quietly to yourselves, read this, answer the questions. When you're done, put your pencil down. Does somebody have a strategy they can explain to the class? Somebody I haven't heard yet would be nice. Somebody I haven't heard from yet would be ideal. Karis, you raising your hand? How do I do this?
So what I did, since one of the sides is 5 centimeters, the other side I started off with is 11.
Okay, so you know that since one side is 5 centimeters, the other side is also 5 centimeters. Okay. All right, continue.
So that equals 10.
Does that give me the perimeter, though?
No.
What's missing?
20. Wait, so 10 plus 10. Wait, no.
I'm missing something. They didn't give me something. Tell me what I'm missing.
You're missing 20 centimeters.
Don't tell me that just yet. It's not 20 centimeters. Okay. Can somebody help her out? Talise?
I divided 35
Why did you divide?
to see what the other side would be. To
Okay.
see like what times 5 would equal 30.
Okay. And why did you do that? There's a formula you're using for that. What formula are you using? Can somebody help her out? Jayla? Go ahead and save it. She's right, but that comes from something. We have to have a reason for using that. She's dividing by 30 by 5. Why? What's she using? There's a formula she used for that. Okay, but yeah, she's using inverse operation to solve for something, but what is the equation to begin with that she's using? Where does this come from? Where's 30 centimeters squared come from? And what is the area? Thank you. There's a formula for area. Area, shh, quiet. You guys took a long time, so nobody gets to claim it. Area equals the base times the height. That's what we just used. We know something about one of my dimensions, right? What dimension do we know? We know the area, but we know the height. Very good. We don't know the base. So in this case, the base is unknown, but we know the height, and the height is 5 centimeters. But guess what? We also know the area, don't we?
Yeah.
What is the area?
30 centimeters squared.
It's 30 centimeters squared. Now we have an equation, and this goes back to what Talise was saying. Talise, you said we're going to divide 30 by 5, right? Okay, that's because we're using this equation, the area formula for a rectangle. So now we're going to solve for my base by dividing both sides by 5 to get b by itself. So I'm going to divide this side by 5 centimeters, and I'm going to divide this side by 5 centimeters. So what happens is these cancel out. They become 1. 5 centimeters divided by 5 centimeters becomes 1. So that just leaves me with a b over here. But now 30 divided by 5 is what?
6.
That is 6. And then centimeters squared divided by a centimeter, well, that just leaves me with centimeters. Okay? So, and I'll explain to you guys those rules eventually, but 6 centimeters is equal to the base. Now, if we know the base is 6 centimeters, now we can find the perimeter. What's the perimeter going to be? It's going to be 22. If you want, we can use this all over again. This is the formula that they're typically going to give you in a textbook. So we're going to use that. Okay, and remember, you can use length and width and base and height interchangeably. So I'll change this just to make sure we have that. So I have the base, and then our base is 6 centimeters. And then I have the height, and our height is 5 centimeters. Okay. And when we simplify that, we see that 2 times 6 centimeters, well, what is that? That's going to be 12 centimeters. And then 2 times 5 centimeters, 10 centimeters. And then what is 12 centimeters plus 10 centimeters? That gives me 22. Not centimeters squared because you're adding, you're not multiplying. It's just 22 centimeters. Okay, last slide of the day. What kind of angle is formed by perpendicular lines? I didn't say what the measure is. I said what type of angles. Right angle. A right angle. And right angles are always 90 degrees, right? Okay, so shh. This question threw some people off, so listen very carefully. If you have 2 parallelograms, and they both have the same height, and they both have the same, their heights are congruent and their bases are congruent, we need you to see if these next 2 statements are true or false. So for the first one, 2 parallelograms must be congruent. Is that true?
No.
Why not? You know, students throughout the day struggle with this. Let me give you a drawing, because I think if you understand the drawing, it'll make sense to you. So watch. I need you to stop talking, because if you didn't answer, I need you to listen so you know how to answer it the next time. So that's going to be my base. And this will be my height. Okay, 90-degree angle. So we're going to draw 2 parallelograms. But this one I'm going to draw a little differently. I'm going to keep the height the same. I'm going to keep the bases the same. But watch what happens. And this is going to be a lead-in to the next question. Now if I connect these up, That's still a parallelogram. That's a parallelogram. They still have the same bases. They still have the same heights. But are they the same parallelogram? No. So this one's false. Okay, now for the next one. The areas of the two parallelograms are equal. Are they going to be equal?
No.
What's the formula for the area of a parallelogram? Base times height. Did the base and the heights change? No. So does that mean the areas are going to be different? The area is going to be the same. So this is true or false? True. Okay, so these last two questions, the first one, most every class got. The second one, most people messed up. So for the first one, if you look at the parallelogram here on the right, you're going to fill in the blank. The formula for area is area equals base times height. What goes in the blank here? 4. 4 is the height. Okay? Most classes got that. The next one, half the people out there messed this one up. The formula for perimeter is P equals
3.
Some of you guys jumped out and said 5. It's not 5. Listen. Shh. I need you to know it. Not just fake like you know it. I need you to know it for real. Look, remember perimeter is the distance around. If I walked around this, I'd have to add it all up and come back to where I started, right? So from here to here, I walked 5, then I walked 3, and then 5 more, and then 3 more, right? So you added up 5 twice, but I have to add up what else twice? 3. The 3. Now, some students insisted on 4, but if I go across that segment 4, am I going around the shape? That's not definition of perimeter. So do you guys understand why that's a